Hey, it's Mr. Allred, and we've been working with exponential functions, and more specifically the population function. So I've got a couple practice problems here. The first one is a new species of insect is discovered, and 40 specimens are collected to study. After 8 months, there are 97 specimens present. Assuming the insects are reproducing exponentially, write a function that can be used to calculate the number of insects present after any given number of months after collection. Also, predict the number of insects present after 15 months. So the first thing here is we're doing a population function, and that function looks like P of t equals P sub 0 times a to the t. So a few things we have here. We know that when we start, there are 40, and after 8 months, there's 97. So what we're going to do is we're going to plug in the information we have. We know that after 8 months, there's 97, so there's 97 for the P of t. It starts with 40. And we don't know the rate, the base A, but we do know that that happens after 8 months. So it says round to 4 decimal places is needed. So we're going to solve the equation 97 equals 40 times a to the 8th for the A. So 97 divided by 40 is 2.425, and that's going to be equal to a to the 8th. So now we're trying to get rid of this exponent of 8, so we're going to take the 8th root of both sides. So that will tell me that 8 is about, I'm going to keep 4 decimal places, 1.1171. So that's the A. So I'm going to write that function with the A in it as P of t equals the 40 I start with times 1.1171 to the t. So that's the function that it's asking me to come up with. And then when it says what would we have after 15 months, we're going to say P of 15. So we'll plug that in. So the t that we found, or the a that we found, goes with t being in months. Okay, so I'm going to have, I'm using my calculator, 40 times 1.1171 to the 15, and I better get something bigger than 97. So I'm going to hit equals, and I'm going to find out that P of 15 here, that means after 15 months, there's 211. So that's a rough estimate, but I kept my A to 4 decimal places. If you want to see what comes out of the calculator exactly, it's 210.5915. But we're going to go with the 211, and we found our function in the process. Okay. Another practice problem dealing with the population growth. A software company has 87 employees in 2015 when they release a popular app. In 2020, the company has grown to 890 employees. Assuming exponential growth, write the function and use it to predict the number of employees for the future and determine how many people will be working there. Let me pause this to correct that typo. Okay, I apologize. Let's see what we got here. We got that we had 87 employees in 2015, and then in 2020 we have 890. So let's use that information. So we're going to once again use our P of t equals P sub 0 times a to the t, our population growth formula. So we're going to say that we ended at 890 employees, and we started at 87. Okay, and we're looking for that A, but that went from 2015 to 2012, so that was over a 5-year period. So I'm going to divide out that 87. So 890 divided by 87, I'm going to stick with my 4 decimal place rule here, but it'll be 10.2299 equals a to the 5th. And to get rid of that 5th exponent, I'm going to say 5th root of both sides. Okay. I'm actually going to go back and retype this value to make sure I get it all in there, or at least get the approximation we got here. So I'm going to take the 5th root of 10.2299. And I get about 1.5921. Okay, so the population formula I now have the A, but it will be P of T starting at 87 times base 1.5921 raised to the T. And this T is in years. And it says predict how many people will be working there in 2028. So that is 13 years from 2015. So I want to find P of 13. So 87 times 1.5921 raised to the 13. So I'm going to do this in my calculator and tell you what I get. I think it's worth rounding this to a whole number as well, since we're talking about people. Ooh, this is pretty silly. So maybe we shouldn't assume exponential growth forever, but maybe we should. 36,740. So if this company continues to grow at the rate it's been growing exponentially, that is quite a leap from the 87 employees they had 13 years prior to that. All right, thank you.